First, let's take a look at adding and initializing disks and selecting the MBR or GPT partition styles. We're going to take a look at some of the options available in both Windows 7 and 2008 Server, as far as implementing basic and dynamic disks and different configurations of RAID like mirroring or striping or RAID 5. So to take a look at that, first I'm going to throw a shortcut to my computer on the desktop. And you want to go to disk management. Maybe one of the easiest ways to get there is just right click and say manage from my computer. And for this, well, it depends on what you're going to implement. For mirroring, you need at least 2 physical disks of the same size or partitions of the same size. And for like RAID 5, you would need 3. Now, RAID 5 is not available in Windows 7. It shows up on the menu, but the option's not actually selectable. Or you're not able to implement it unless you're running like a 2008 Server product or 2003 of it. In this case, I've added 3 small disks, alright, and they're 5 gigabytes. And you can choose how you want to add them and initialize them. So when you first add them, notice that this little menu will pop up, and you can choose MBR, that's the normal Windows default, or GPT, which is, if you're using Apple products, a lot of times Apple uses that type of formatting. Or if you're doing a multi-boot, I do multi-boots. I may put Leopard on one partition and Windows 7 and 2008 or Linux on another partition, in which case, again, I'd probably choose MBR. So you can let the wizard do it for you, or if I wanted to, I could bring them online manually. So the easiest thing to do would just be to click on OK. But just to show you some of the different options, I'm going to click cancel, and I'll bring them each online manually so you can see what that looks like. So I'm going to click cancel. Let me expand this here. And then notice this is my operating system partition in Windows 7, and it tells me what it is. Obviously we've talked about extending and shrinking and things like that before. But these are the 3 volumes that I've added so far, and notice that this is healthy, the partition's there. Notice these guys here that that I've added, it says unallocated, and notice the little red down arrow there. They're down, they haven't been initialized. So I could have let the wizard do that for me, but I just want to show you, if I come over here to this little gray square and I click on it, notice I can manually say initialize disks. And if I want, now I'm going to go ahead and let the wizard do that to bring those disks online one by one. Alright, so once I do that, they're online. Physically they're there, but notice that I still don't have a partition. Alright, so I can't assign a drive loader, I can't store any data there until I generate or create a file system, either FAT32 or NTFS, some kind of a file system. Also notice that by default when I add them, they are basic disks. Now for a lot of things that you do, basic disks are fine, especially if you're doing a multi-boot. Most of my systems, personally, my laptops, my desktops at home, I do multi-boots because of all the crazy stuff I mess around with. Yeah, sure, it wastes a lot of hard drive space, but a lot of times I need 3 or 4 different operating systems on one computer. It's not enough simply to be able to run virtual machines. Sometimes I actually need to reboot and go into Linux, or go into Snow Leopard, or go into Windows 7 or Vista or XP or something, 2008 Server. So I like to have that option, and I don't want to have a different computer for every single operating system, so I do a lot of multi-boot configurations. If that's your case, then you probably want to shy away from dynamic disks, in which case most of what we're doing with RAID and things wouldn't be practical for you, because once you convert your partitions or your disks from basic to dynamic, they're very unfriendly and very incompatible with other operating systems, such as Snow Leopard or Linux. So what I'm doing here, you wouldn't want to do if that's your situation. I wouldn't really do this on my laptop. I wouldn't want to do this on my workstations at home, only on a server where I want to implement RAID or mirroring or striping or something like that, and where I'm not multi-booting it. Typically you wouldn't do that with a server because you want to run it 24/7. So for that situation, then dynamic disks would be a good thing, because you get a lot of extended functionality with dynamic disks in Windows that you don't have with basic disks, provided that you don't need backwards compatibility or multi-boot compatibility with other operating systems. So that being said, these drives here, I'm going to dedicate, no multi-booting here, nothing, just basic Windows 7. So notice my options here. I can convert to dynamic disks. Now, once I convert to a dynamic disk, I can't go back without, I have to copy off the data, and it would pretty much just, I'd lose it, I'd have to reformat it and start all over. Now that's with the built-in Windows tools. Now there are tools I use like Paragon Partition Manager and Partition Magic. They will let you convert back and forth from basic to dynamic and back from dynamic to basic without destroying the data. Just like they let you move and resize partitions and do all kinds of crazy things that Windows doesn't necessarily let you do by default. But in this video, I want to stick to just the basic tools that Microsoft gives you. So yes, there are third-party tools that will certainly let you bend or break the rules and let you do all kinds of great things. But maybe we'll just stick to just the Microsoft tools here in this example. So again, in its MBR, I could convert to GPT, or from GPT to MBR if I did that. So like, let me take this disk 1 here, convert to GPT. Okay, and if I right-click here and go to Properties, notice that now it says Convert to MBR disk. So I can convert to MBR. And you can see if I go to the Properties, just go in, click on Basic Features here. Here's a GUID partition table, GPT, and that would be more compatible with like Leopard. And there are different limitations as well. Remember, GPT gives you, you could do like 128 primary partitions. You only get 4 primary partitions with a basic disk. There's all kinds of things, differences between the two. But I'm going to convert it back to MBR, just because I want to build this array in sort of the standard default Windows format. So just exploring that option. Now, if you wanted to physically take the drive offline, you could take it offline. Look at the little red arrow there. And again, you can get help on that, but we know the down red arrow, hey, that disk is down, so I need to bring it back online. And the first time I had to initialize it. Now, I still haven't created any partitions here. It's unallocated space. But we're just exploring some of these features, some of these options. Okay, now, creating a simple volume on a basic disk. What I could do over here, I could right-click and I could make a new simple volume. That's the very first thing I'll do. And this doesn't really involve having to have a dynamic disk. You can do it with a basic disk. It's nothing special, no RAID level, no mirroring, nothing like that, but just a basic volume, right? So the easiest thing to do would be to make this the full size. So I'm going to do that. Notice you can pick drive letters, but by default it'll take the first unassigned drive letter. You can mount it to a folder like you would in Linux, but we're not going to do that. And I could give it a volume here. I'll just call it data. All right, I'm going to do NTFS now. There are other videos where we've talked about the differences in these file systems, so again, I'm going to be brief. I don't want to repeat information in one video that's been covered in others, but remember, just a brief summary or a brief review. Remember the differences. FAT32 doesn't support file sizes over 4 gigabytes. NTFS does. FAT32 doesn't give you encryption or compression. NTFS does. FAT32 does not really have a permission system. Alright, whereas the new technology file system, or NTFS, gives you the discretionary access control list, or the DACL DACL, and the access control entries, the ACEs on that DACL, so you can configure groups and users and permissions for files and folders and objects. So you get a lot more features with NTFS, in addition to enhanced data recovery capabilities and drive usage. There's all kinds of reasons why most often you would want to pick NTFS. The only reason you wouldn't pick NTFS is if for some reason you need to make a partition or a drive backwards compatible with some other operating system or some application or something like that. But NTFS, there's even plenty of tools out there in Linux that let Linux by default now. Ubuntu, I use Ubuntu, and it mounts NTFS and reads and writes to it quite easily and reliably by default. So, and you, depending on if you use the Fusion kernel, if you use Leopard or Snow Leopard, or what is it, Lion now, whatever the latest, same thing. When I use Snow Leopard, when I, depending on the text files that I implement or set up, it can read and write to NTFS just fine. So, really, there's no reason not to use NTFS I can think of, like I said, unless you just have, for some reason, you need to make something super backwards compatible. So, next, and just to show you what happens, it will format. This is a simple volume. It'll format it, and so right now, in this case, physical drive, the metal platter spinning, the little magnetic heads going back and forth across it. The voice coil, the stepper motor, and it's laying down magnetic lines of flux with the formatting that will support all of the things that NTFS supports. So the clusters, the data, when it's stored there, the sectors and everything, they will all support encryption and compression and a permission system and enhanced data recovery capabilities, all the things that you get with an NTFS file system. So notice now that it has been formatted and I have a simple volume and it's still basic, I haven't converted to dynamic yet, it tells me it's healthy, and there it is. And if I were to minimize this, and notice that this pops up here, and this is kind of a little buggy thing here. It sees it, wants to, once it mounts it as a drive loader, wants to format it, but we already did that, so just cancel. You don't want to, no point in reformatting it. But notice here it is. And now I could actually store data on that partition. So let me click on computer here, and you'll be able to see. All right, so here's my operating system drive. It's basic NTFS. Here's the new drive that we just added, physical, and formatted as NTFS, and there it is. It's basic, and I can store a data file on that if I want to. I'll just make an empty text file. Alright, and it's good to go. And so we can see file extensions. Again, let me go here and here, uncheck these options, uncheck that option, and that'll give us the DSL security tab. Just make a few modifications there. Alright, so now you can see the .txt. And of course my hidden desktop INI file shows up now because I'm showing hidden files. But alright, so that gives you an idea of a basic, simple volume. Now let's take a look at using the shrink tool to create unallocated space for additional partitions. Okay, and notice there are a few other features we could also explore while we're on the topic or on the subject of a basic, simple volume, and that would be extend and shrink. And let's say that, there are plenty of situations where these tools are useful. These didn't used to be built in. You used to have to use, like I said, a third-party tool, Paragon, Partition Manager, or Partition Magic, something like that. It's kind of cool. Now they're built right into Windows 7 and Vista. But if I want to, this is all one partition. But let's say for some reason, what if I had a big drive, 500 gig or a terabyte or 2 terabytes or something, and it was all one partition. I've done this before, and maybe I just had an operating system on it, like Windows 7 or and I wanted to add, do a multi-boot and add another operating system like Linux or, a server product or something like that, or Snow Leopard. Well, I couldn't do that on the same partition. But if I have free space, one of the cool things that's built right in is we can shrink this volume. So yeah, we're using up all 5 gig. And, this is just an example drive, but, a large drive, like I said, it could be a terabyte, 2 terabytes, whatever. So if I wanted to shrink it, notice that it'll query the volume. It'll say, hey, this is how much free space you have. This is how much you can shrink it. I can enter the amount of space to shrink by. So what if I wanted to cut that drive in half? So I could do, let me turn on my number lock here, 2500, like the 10 key. All right, so 5 gig, let's say we were going to cut it in half. I could shrink it. So notice now I went from 5 gigs to 2.5 gigs. Now I have another partition here. And so if I wanted, I could create another partition, a new simple volume. It's still basic. And again, this is a small example because I don't want it to take a lot of time, and I'll call that one data 2. But, typically a larger example, like I said, you'd probably have a 500 gig drive, terabyte, 2 terabyte drive. So I could split this up into multiple partitions, and then I could have Windows 7 on one partition, and Linux and a swap partition on another, and I could do logical extended DOS drives, and maybe have Snow Leopard on another, and 2008 on another. There's all kinds of things I could do there. Now I have 2 permissions, and I pretty much cut it in half using the shrink tool. Alright, and notice that would be mounted as and appear as another drive loader. And again, you can just ignore the format because it does it for you. Notice they're both healthy, but if I were to go look at that, let me go here and see how that looks on my computer. So now I have an E and an F drive, and it's the same amount of physical space, but we split it up into 2 partitions. And typically use it for multi-boot. Another thing I like to use it for on my systems, and systems at work, I like to make a data partition. You store all the data on one partition, you put the operating system on another. And that way you can deep freeze it. So I deep freeze the C partition, and so I don't have to worry about people deleting files or doing bad things to it. I just reboot and it's all undone. And then if they want to save their data, store their work and whatnot, they store that on the data partition. Also, this is the partition that I would use an imaging tool like CloneZilla or Ghost or ImageX to back up. Whereas I can just back up the data partition by just copying the files and compressing it in an archive somewhere. So it's a smart configuration to not put everything on a single partition. If you have a big drive, it's a smart configuration to split it up into multiple partitions. And again, imagine a worst case scenario. Your operating system's host, you got to reinstall Windows. Well, if it's one partition, that means you got to copy off all your data, and put that on a drive somewhere, and then install it, and then copy it all back. But if you split it up into more than one partition, you could just format and install Windows on the partition that's hosed, and all your data stays on the other partition untouched. You don't have to copy it off and copy it back on. So, there's all kinds of reasons. Being able to deep freeze one and leaving one thawed, having it on one so if it gets hosed you can reinstall it, and just all different ways of backing partitions up. There's all kinds of reasons. Finally, you actually get a performance advantage. If you have a huge, large drive and it's all one single partition, like a terabyte or 2 terabytes, your performance is going to be much slower seeking and reading from that huge partition than if you took that drive and you split it up into smaller chunks or partitions, put your operating system on one and your data on another. You'll notice that your seek time will generally be less and access to the drive will be faster. Even though physically it's not spinning any faster, and physically you haven't increased the seek time of the arm, the magnetic head moving across the platters or anything. Well, that's if you don't have a solid state drive. The actual partition size is smaller, and so data access times can be faster. So there's all kinds of good reasons why you would want to do that, or why you might choose to do that. But let's go back and let's say we wanted to undo it. Let's say we had a multi-boot, or we had our data, and now all of a sudden we've run out of space and we need more space on our hard drive. Now let's try using the extend tool to increase the size of a partition from unallocated space. So let's go back to Partition Manager, our disk management, and let's take a look at here are our 2 partitions, and we've used the shrink tool. Now the opposite of the shrink tool is the extend. So if I pick a partition and let's say that I want to extend the volume, I can't really extend it unless I have free or unallocated space. Okay, notice here are 2 physical drives, and I could extend this volume to the other drives. In other words, I can't extend it any farther on disk 1, physical disk 1, but it's letting me know, hey, you have unallocated space on disk 2 and disk 3, and if I wanted to, I could extend it there. And notice that I could create a 12 gigabyte partition that would span across those disks if I wanted to. But to actually, pretend, or let's say that these physical disks don't exist, if I only had this one physical disk here, then there would be no way that I could extend this. Were it not for the other drives, I'd have no means of extending this beyond its physical limitation of 5 gigabytes. So to do that, I'd have to delete it first. So I would delete the volume. When I do this, it'll create unallocated space. So see, now I still have my 2.5 gig partition here, but now I have 2.5 gigs of unallocated space. So again, to do the opposite of the shrink command, if I were to use the extend command and extend the volume, I can right click on that partition, next. In this case, I could choose just physical disk 1. We won't do a span partition yet. I'm going to say next and finish. And when I do that, now notice that my partition is, once again 5 gigabytes, but I only have 1 instead of 2. And if I were to browse, let me click on computer here, and notice that my data was not destroyed in the process because I never actually, deleted or formatted my first partition. So it's kind of cool that Windows can do some non-destructive partition table editing. But and third-party tools have been doing that for years. Like I said, one of my favorites. I don't really depend on the Windows tools. I love Paragon Partition Manager. It does incredible things, and Partition Magic is pretty good as well. But even still, with those tools or with the built-in Windows tools, it's always a good idea to back up your data before you do anything that involves editing the partition table, the file allocation table, or partition structure, because 99.9% of the time nothing will go wrong, but something always could go wrong, and you could potentially lose data. So if you had something very important, database files or something that was mission critical or important, you would certainly want to back that up before you do any of this editing or messing around with data. Or maybe it's just photographs that are of your family and they're priceless and you can't replace them. In which case, I would be cautious about managing, shrinking, extending, editing partitions, and moving data around if I did not have a backup. It's always smart to have a good duplicate backup. USB drives are cheap. You can get 2 terabyte size USB drives for $80 if you shop around, or less. It's a small price to pay to back up your data, and then you can do what you want, and you just never know. Yeah, maybe 99.9% of the time it works, but what about that 0.1% of the time where disaster happens? Okay, so just looking at different ways of managing and manipulating a simple volume, right? Everything we've done so far has still been a basic disk. We're going to try using the extend tool again, but this time to create a single span volume across multiple physical disks that contains the sum of their storage capacities. This automatically converts basic to dynamic disks. So another thing that I could do if I wanted to, I could extend this and use the other volumes. Okay, I could do that. Or if I wanted to, I could also create a spanned volume. So I'll just try this option here. If I were to do next, if I were to add this and add this, notice that I could combine, physically, I have 3 physical drives. They're 5 gigabytes each. If I combine them all, I could combine them into one volume that's 15 gigabytes. So even though there are 3 physical drives, they would normally appear as 3 separate drive letters. If I choose this option, they'll all appear as a single drive, spanned across that. And then notice the option here, the operation you selected will convert the selected basic disks to dynamic disks. So again, in order for me to utilize this feature, spanning, striping, RAID, this is where we have to take it from the basic disk to the dynamic disk. And remember the previous caveats. We mentioned that if you're using a multi-boot configuration or you're using operating systems that need backwards compatibility, then you probably want to stick with basic disks. So remember that in this example, this is a server, there's no multi-boot here, backwards compatibility is not a consideration, not something that we need to worry about. So yes, we're going to go to dynamic. We'll let the wizard do it for us. We could right click and do it manually. You saw that on the menu, but this will just show you a spanned volume, okay? Span volume. Alright, and notice it's purple here, and there's a color coding down here, which is so cool. Unallocated space, primary, in this case expand, so the purple, it's a span volume. Alright, and notice how that shows up now. Now I have one drive letter, but even though it's one drive letter, it's actually 3 physical drives, each one of them holding 1/3 of the partition. But it shows up instead of 3 separate 5 gigabyte physical drives, I have one 15 gig partition composed of those, 3 5 gigabyte physical drives. So that's kind of a cool thing on a file server or a database server, where you might have lots of smaller disks that you combine in RAID arrays or configurations, and maybe you want to make them one single volume for storing files and data. So kind of a cool option there. Alright, so once again, now I'm going to go ahead and delete this volume, and we'll look at a few other configurations. Now let's create a simple span volume across multiple physical disks. This involves no striping and no fault tolerance. And now we're back to having 3 basic physical drives with unallocated space, no partitioning structure, no volume system added. And again, if I right click over here on the little gray or white, whatever color that is, square, notice my options. I can bring it offline, I can convert to GPT or back and forth from GPT to MBR. Now notice that this option's grayed out. It's there on the menu list, but that's not really available to you under Windows 7. So you'd need one of the server products like 2008 Data Center or 2008 Enterprise, or something like that. But we can do these options, alright? So what we did before with the extend, this is just another example of extending a partition. So if I went across here, notice once again I could add my physical drives. Notice that it's the sum aggregate total of all their storage capacity. So if I have 3 5 gigabyte drives, I can do a 15 gigabyte partition spanning across those 3 drives. And again, I'll just choose this method. We'll call it data. And even though it's 3 physical drives, it'll mount as one drive letter. Of course, it tells me, hey, you understand that I'm going to convert from basic to dynamic in order to get this done for you. So this is nice about that. And now that it's done, it's formatting them. And notice again the color coding, purple for a span volume. So it's showing me that it's a span volume. Alright, now that it's done formatting, it mounted them all as drive letter E. And again, you can see how that appears in my computer. Now I have one drive letter, even though it's 3 5 gigabyte physical drives, one 15 gig spanned volume or partition across those. Okay, so we're kind of looking at spanning volumes and striping. Now let's take a look at implementing mirroring, okay, or RAID level 1 in this case. So again, I'm going to break this volume set. So I'm just going to right click, I'm going to say delete volume. Of course that would destroy any data that was there. They all convert back to basic disks. Now we're going to implement RAID 0 in Windows 7. This provides striping, but no fault tolerance. Now let's try the next example. So we're going to implement a striped volume, in this case RAID 0. And a striped volume will give us performance enhancements because of parallel simultaneous read-writes across multiple disks, but it doesn't really give us fault tolerance because there's no parity stripe and there's no duplicate set of data like there would be in mirroring. But to make a new striped volume, I'll say next. And again, I'll add all these, and notice that just like a volume that involves spanning, striping gives us the same ability to combine or aggregate those three physical drives into one mounted drive letter. But this also gives us, unlike spanning, this gives us striping, which would give us a performance enhancement because we can simultaneously, any data that would be written, let's hypothetically say you have a 128 kilobit chunk of data or a 64 kilobit chunk of data. Now we can break it up into multiple blocks and bytes and bits and write them simultaneously to all three drives at once and read them simultaneously from all three drives at once. Now obviously we would have to have separate controllers. Wouldn't be like any daisy chaining going on here, but because of that we get an interesting and significant performance enhancement when we implement striping instead of spanning. Alright, so again, RAID 0 or striping. And again, if we take a look at it, notice how that looks. It's those three physical drives have been combined into one striped this time instead of span volume, and it's 15 gigabytes. Alright, so again, I'm going to break that. Now we're going to implement RAID 1 or mirroring in Windows 7. This provides fault tolerance, but no striping. And now the next thing we're going to try is a mirrored set. And this is RAID 1, in which case we're not going to get a performance enhancement, but we can get duplicate copies. So if I were to, I could add disk 1 and disk 2 if I wanted to out of this mirrored set. Now, basically I'm just making two duplicate sets of any drive. And so if I were to do this, I'm going to click next. Notice I'm not gaining any space there, I'm actually losing space. So I'll go back and each of these is 5 gig, and I've combined them and I still only have 5 gigs of space. So I'm sacrificing pretty much one physical drive since I'm dedicating that to fault tolerance, to just backing up the other drive. It's not aggregating or combining the space together. But the neat thing is unlike spanning and striping, in spanning and striping, if I have a failure of any one drive, all my data is lost and I have to restore from backup. That's with RAID 0. Now with RAID 1, when I'm implementing mirroring, if either drive fails, the other drive contains a complete mirrored duplicate set of data. And so the array can still be up and running, and I can actually, if I have a hot swappable RAID configuration, I can actually replace the bad or defective drive and rebuild the mirrored set without ever having to power the system down. So it keeps my, could keep my database server, my system, my cluster, whatever up and running if that's what I needed. And of course this is software RAID, not hardware RAID, but still the principle is the same. Maybe we'll do another one on hardware RAID someday. But alright, so just for now, just sort of the basic RAID possibilities built into Windows 7 and 2008 servers. So this next one I'm going to click next and next. And again, we'll just call it, let's do data. And let me go next. We'll just go with the defaults here. And then it's telling us, of course, what we're saying, hey, are you sure, we're going to convert these from basic to dynamic? Yes, we know that. That's okay. So now this time, instead of RAID 0, like we did last time striping, we're going to implement RAID 1 mirroring. Notice the color coding is different on the map. This is red now. It's a mirrored volume. And notice that even though they're duplicate copies, and I haven't gained any space here, they're not combined, it's just that one's backing up the other, one's mirroring the other, they're both referred to with the drive letter E. And so let's create some data. We'll just make some data there. I'm going to go here and I'm going to make a file. And I'll make a folder. Put something in the file. There we go, 1 kilobyte. Okay, so we've got some data there. Now, when I do that, and everything is written to this volume, physically, it's also written to this volume. And were this volume to fail, I'd still be up and running because all the data is on this volume, or this physical drive. And were this physical drive to fail, I'd still be up and running because this physical drive is running. And they're both addressed as E, alright? They've both been given the drive letter E. Now, what could happen if for some reason, I can break a mirrored volume and I can remove a mirror if I need to. So let's say that, let's say that this drive goes bad. Alright, I can break the mirrored set, so I'm going to say break mirrored volume. Break the mirrored volume, data will no longer be fault tolerant. That's fine, it'll still be up and running. So we're pretending this drive went bad. We're breaking a mirror. Oh no, 7 years of bad luck. Well, not that kind of mirror. But anyway. Alright, so we broke that mirrored set. Now notice that we have 2 drive letters. Okay, so now I can actually have 10 gigabytes instead of 5 gigabytes of space. Now I have 2 drive letters, before I only have 1. But I'm not automatically backing up this drive. Anything I put on this drive now is no longer also being copied to this drive. No mirror exists there anymore. Okay? But if you wanted to view that, you could verify that. Look, we'll go into my computer, we'll look at these drives and notice that on E, there's the data folder and the new text document that we created. That's on E. Now let's go to F, and look. There's the data folder and the new text document that we created. So you can see that it's an exact mirrored duplicate or clone of the original drive, and that does give us fault tolerance. Well, not now that we've broken it, but before when we had implemented it. Now let's try rebuilding a mirrored set after a disk failure. Okay, and back to our mirrored set. Remember that again, these are 2 physically identical drives with the same size, and any data that we write to this drive is automatically written to this drive. So it keeps an exact duplicate. Now let's say that there were a failure. The second physical drive for some reason failed. So in this case, I'm going to take it offline, now to kind of emulate a failure. Notice it tells us, hey, there's a failed redundancy for one reason or another. And then I could choose to remove the mirror if I didn't want fault tolerance, but if I were to bring this drive back online, notice the little exclamation point there, and then here, let me go here, and in this case notice I would want to choose import foreign disks, and I'm going to say OK, and a mirrored volume, data not redundant, I'm going to say OK. And notice now, I have 2 drives mounted with 2 drive letters, and once again notice that they both have duplicate sets of data. Okay, so let's go back to disk management. Now in this example I've broken the mirrored volume. Okay, so if I were going to do that, all I'd have to do to implement mirroring again would be to add the new drive. So again, let's say that for some reason this was lost completely. I'm going to delete the volume here. Right, and that's so basically this drive was totally destroyed, but this drive, because it was mirrored, I still have the data. So all I have to do is I would add my second drive, I'd bring it back online, and then I could come over here and I could say add mirror and choose disk 2, and yes, and once again it would be able to implement or use that second drive to mirror itself. So all the data on the first drive would then be copied over to the second drive, and once the mirror set is complete, any new data that would be added to that drive would also be copied to the second drive. So again, I'm getting fault tolerance. I'm not getting any performance enhancement like I would with striping or RAID 5, but I am getting fault tolerance because if either drive fails, I still have a complete set of data on the other drive, and my array can still be up and running if my drives are hot swappable. Notice it says resyncing, which means that any data on the first drive, it's now copying to the mirror and the mirrored set. And notice the color coding down here. It's a mirrored volume, so it's red there. And as soon as it's done resyncing, then we'll have a complete set of the data on both drives. And notice that even though they're physically different drives, they're no longer separate drive letters. They're both, referred to as E. So one's just a complete mirrored copy or set of the other drive. Okay, and now we're done, and they're both healthy, and they're both E. And once again, if we were to look at that in my computer, now we have, one drive letter that's a mirrored drive, and duplicate sets of the same data, providing fault tolerance. Finally, we're going to look at implementing RAID 5 and Windows 2008 Server. This provides both fault tolerance and striping. Now remember, we couldn't implement RAID 5, even though it is available as a menu option in Windows 7. But this is 2008 Server, and we can. So I'm going to right-click, and I want to go to the same place, Disk Management. Now in Windows, you need a minimum of 3 physical disks. You can have more, but not less, to implement RAID 5. So that would be two disks for data striping, and you need 1 disk to hold the parity data, or the parity stripe. And the idea is if the parity disk fails, well, you've still got a complete set of the data. And if either of the data, striped data disks fails, you can rebuild the data from the parity. Okay, so you have, you can tolerate losing up to 1 physical drive in a RAID 5 configuration, either the parity drive or either of the data drives. And therefore, RAID 5 gives you some fault tolerance in the sense that you can lose a drive and still keep up and running, albeit at decreased performance. And in addition to that fault tolerance, it gives you a performance enhancement because you can do striping. So you can do parallel simultaneous data read and writes, or I/O operations, on multiple drives. And that is quicker than breaking a piece of data up into chunks and writing it simultaneously is going to be faster and give you more aggregate bandwidth than trying to write that to just 1 physical drive. Alright, so I have 3 physical drives here. They need to be the same size. Now right now they're all offline. I just added them, so notice the down arrow there in 2008 Server. So I want to bring them online. Okay, need to initialize the disks, and let's bring them online. Alright, and let me bring 2 online, and let me bring 3 online. Alright, now they're online now, but I need to initialize them. Alright, so I'm going to initialize. This will bring up the wizard, and I'm just going to let the wizard do it for me. I want to initialize them all. Alright, so they're all initialized, they're all online now, they're all basic. Now of course, for any kind of RAID configuration, RAID 0, RAID 1, RAID 5, striping, I need to go from basic to dynamic disks, and I'm going to let the wizard choose that or do that for me. If I right click, notice my options here: new span, new stripe, new mirror, just like you have in Windows 7. But unlike Windows 7, where this option is grayed out, in the 2008 Server products, this option is not grayed out. So now we can do RAID 5. And I'm going to choose that option. I'm going to say new RAID 5 volume. Next, and it's only available because I have a minimum of 3. If I didn't have 3 disks, again, I would not meet the basic requirements for implementing RAID 5 in Windows. So I have 3 drives, physically the same size. Next, it will be mounted as E. Now, once again, notice I don't get any I don't get any storage space aggregation or gain here. In this case, at least from the one being used for parity. I mean, I get, I'm combining these two with Stripe, and I get 10 gigabytes from the 5, but I have to sacrifice 1 physical drive just for storing the parity information necessary to rebuild the data if either stripe volume fails. Alright, so that's fine. So select the amount of space in megabytes, maximum available space in megabytes, yada yada yada, blah blah, total volume size. I'm just going to go with the defaults. Next, let's mount the drive as letter E, so it'll show up as E. We'll just call it data. That'll be the partition name, NTFS of course. And yes, and we'll let the wizard go and configure the drive. Alright, and now that our RAID 5 configuration is done, we'll go here, and just to show you, it will mount as a single drive later. Let's see how it looks here. Alright, so we have 10 gigs, so we're able to get the combined size of two of those physical 5 gigabyte drives, 10 gigs of storage, but we've lost one of those. One of those 5 gigabyte drives is used for parity information to rebuild the RAID 5 stripe set in case one of those volumes fails. Remember, the requirements for this are that you need at least 3 drives, physical drives of the same size, and they also need to be on separate controllers. So, serial ATA or some other drive configuration, but you wouldn't want to be using like parallel ATA or EID drives that are daisy chained that are on the same controller. That wouldn't work. And hopefully, preferably a main board with lots of drive controllers, a higher end server main board that supports RAID.